this is Check Point proprietary work. At Check Point, I founded the vulnerability disclosure operation. That means that when you find a vulnerability in a product that is causing its exploitation to harm someone, basically the vendors, they don't want to fix it. They prefer to move on, because if you need to fix the bug, then it's programmer time that is not used for the next version. So the way to usually force them to do that is by twisting their hand and saying, look, we found a problem and we're going to publish it. So you might want to be able to say, oh, it's okay, it's fixed. This is the balance. That's how it works. And the amount of time that you give the vendor to fix a problem is usually based on how sophisticated it is to fix a problem and deploy it. If it's a web page, they can do it right away. If it's an ATM firmware, someone has to develop a firmware and then go to the ATM and update it, because not everything is remotely updatable. But there's no actual standard. You do whatever you want. And after you let the vendor fix the problem, you give them enough time, then you go public. That's the difference between responsible disclosure and full disclosure. Full disclosure means you go out, you speak, you tell everyone what you did. Sometimes you will provide proof of concept, but that's not a good idea because that's a loaded weapon. And if there's any instance of the vulnerable software or product that was not patched, then it can be attacked. So we prefer to not give proof of concept. Worst case scenario, you show a video of you exploiting the vulnerability, but you don't give the tool. I'm going to give a few examples. I'm going to rush through them. It's more important to listen to me than to read the text. Text is not important. When you go to the cinema, you no longer buy the ticket at the cinema. I mean, you can, but most people don't. You buy it online. And then when you go to the cinema, you have one of these devices. You just swipe your card and it prints the ticket. Sometimes it will let you buy the ticket as well. And basically, it's a hardened device, okay? There's no keyboard, no ports, so you shouldn't be able to be messing with it. However, this is a disclosed bug, okay? They already fixed it, so I can talk about that. For some reason, the top menu was not disabled, and this is a touchscreen, which means everyone can press it. So you open the menu, and even though it's in English, I'm going to tell you that the print settings options was still working. Everything else wasn't, but this one was. I don't know why. Maybe they thought it was not dangerous, but if you do that, you get this dialog, which actually lets you print, or this button, network, lets you add printers. Adding a printer means it opens a little Explorer window where you look for printers, but this is a limited window. It only lets you look for printers. You can go and execute files, which is what the attacker always wants. Okay, full code execution. However, this touchscreen is fully compatible with human interface device, keyboard and mouse, which means if you press it for 2 seconds, you get a right click. And when you do a right click on a directory name, you can open it in a new window. And when you open it in a new window, you get a fully functional Explorer, which means you can do whatever you want. Now this is Windows XP, it can be Windows 7, doesn't matter. The first thing you look for is OSK, on-screen keyboard, right? So I did that. It's not part of the display here. But what I did do is I started looking around. And all of a sudden I found a directory name called credit, which is what I was looking for. And if you go inside, there's a long list of files called tran b and then a number. You want to guess what tran is? Transaction. There you go. So I use a very sophisticated hacker tool called Notepad. And you drag one of those files, bingo, unencrypted credit card information. Every credit card that was passed through that magnetic reader, the content of the magnetic stripes was put in a text file. Now that's a problem, okay? Now, it's not illegal. Maybe they're assholes, but it's not illegal. Maybe they don't comply with PCI 1, but they're not committing a crime, depending on the country. In Israel, it wasn't a crime at the time.
Who is them? The one using it this way?
Whomever wrote the program.
Oh, okay. Not
Right.
the one,
If you just own the device, you're not responsible. So, what I want to do is I want to take that home, the credit card information, because I'm a hacker. So obviously I can take a photo, right? The problem with that, well, a number of problems. First of all, there's a limited amount of information you can get from here. Second, you would need to either type it or use an OCR. And from experience, when you stand in front of this device and you start taking photos, people come asking questions. Specifically, it was the cinema manager that came and said, "Excuse me, can I help you?" And I looked him straight in the eye and said, "No, it's okay, there's a security problem here and I'm working on it," which was true. Now, I did not say I work for the company, I did not say anything that wasn't true. So he looks at me back and he says, well, thanks for coming. There's also a problem with the printer. You could fix that. This is social engineering. I didn't lie, but I led him to think something that was in my benefit. But I have a printer, so I can print the card, okay? This is the paper that they use for the movie tickets. So now I have a printed version of all the credit card numbers. So, that's not all. They actually have the RSA keys and certificates on text files on the device. Once again, printed, and I was supposed to scan that, but this is the tear line because it's a movie ticket, so you have to manually fix some letters, and then you get all the information. So now not only can I steal your credit card numbers, I can actually bill your card, because this is the encryption that they are using with the billing service. So, to summarize this sophisticated attack, the purpose of the device was to print the movie ticket, maybe let you buy it. What we actually got was credit card information and encryption keys. What sophisticated hacking tool did I use for this? No. Which means every one of you can do that. Alright? So apparently I've started a thread, because I've been giving this talk for a while, and most of my friends have seen it, and then we started corresponding on Facebook. So a friend of mine says, we have Ruth. This is a cinema place in Israel, another one. So, of course, I have to reciprocate. This is the post office. This is the computer that just prints the number you are in line. You want to pick up a package or you want to send one, you get different lines. You're number 35. That's what the device does. I got full control, and it's on the network of the post office, so I could have done whatever I wanted. So I posted it back, and then they're like, okay, we have another one. And I'm like, okay, how about the Jerusalem municipality? Well, we're at it, right? So it's fun.
Did you try ATMs?
No, because most of them don't have a good interface that lets you do stuff. However, many of my friends found ATMs that were outside their software. That happens a lot.
Happened to me.
It happens a lot. Point of sale devices. This was not in everybody's consciousness until the Target hack, because they stole information from point of sale devices. But every business has them. That's how they bill your card, right? This is a restaurant in the US, a roadside restaurant. For some reason, there's a sticker with the IP address on the device. Now, I don't know if you know, but in the United States, they actually call waiters servers. So maybe they thought that the servers needed to know the IP address. Like they would. Now, Israel, as you might have noticed outside, has a very good weather, which means in Tel Aviv, we allocate sidewalk space for chairs and tables. So this is during the day, right? You sit outside, and here there's a point of sale device. Because if you sit outside, then the waiter just needs to go here, punch in the order, and the kitchen already starts preparing, right? So at the end of the day, because we're Israelis and we steal everything, they have to put everything back inside the store, and they lock the store. But there's one thing that is left on the street. This. Now, to you, this might mean a lot, but for them it doesn't. For the simple reason, they're not in the business of cybersecurity, they're in the business of making coffee. They have no idea what this is. But this is connected to the local area network of the business. Okay? Everything else inside the perimeter is sitting on the same network, and this is outside on the street. So I just show up with my laptop and a network cable, which I always have in my bag, and I start looking around. Now, like a good intelligence officer, I start listening. I'm not being like, okay, let's see. What's going on? I'm scouting. Using an open source and a free software called Wireshark, I'm just listening to packets. I'm not transmitting anything on the network, so I can't be detected either. And there's a lot of information going on here, and if you know anything about network traffic, you can read that, and you start recognizing protocols and identities. You have IP addresses and everything. And to sum it up, we have 5 servers that respond, and we start attacking. Okay, that was the end of the intelligence collection, and now we're attacking. So SMB is a file sharing protocol for one computer to offer access to its files to another computer. And because I saw evidence of SMB protocol, then I start approaching the responding servers in SMB. And I say, hello, I would like access to your files. And this is done with the operating system of the OS X, of the Mac. I'm not using any external software. And I'm saying, hi, I'd like to connect to you. So of course the response is, based on the protocol, are you a user or not? Now, I don't want to lie. So I said, I'm a guest. Now what you expect to receive as a guest is no access. what you end up getting is full access to 2 hard drives inside the computer, because the point of sale device is basically a PC running an XP operating system. Okay? Full access as an administrator to all the files. Now what can you do with that?
Yes.
You want to start by establishing attack vectors, because remember, I'm standing on the street connected to a wall. Now I have a good story, I can trick police, but you don't want to do that for a long time. You start looking around, you find huge database files. Now imagine what I can do with that. Maybe it has your transaction history, maybe it has your all your contracts with your supplier. If I'm your competition, and I know the prices that you're paying your suppliers, I can drive you out of business and no one will ever know anything, because nothing really happened. I didn't threaten you. You don't even know I stole your information. It's just, it happens. And there's a huge file called admin, and look at that, Tran B001. And you already know what that is. They're using the same system, once again, credit card information, in a non-encrypted text file. Only this time, I don't need to print it on a piece of paper and connect it to the drive. I can copy the whole thing to my server and just walk away with the entire credit card transaction history of the business. Just think about that. Next thing I do, I want to generate a list of all the files, okay? I don't want to copy the files because I'm a responsible disclosure. I'm an ethical hacker. If I copy anything from that server, okay, then I'm not responsible for it. And I might have created a new threat, because if someone steals it from me, this is a threat that did not exist before. Now everything you're seeing here, these are all screenshots. I didn't actually take anything. I'm taking a screenshot and I'm leaving. So my computer doesn't actually have anything that belongs to that other guy. Otherwise, I'm creating a risk. It's slightly outside the ethical hacking boundary. So I make a list of all the software, which is good enough, because that can give me a list of all the tools that they have, and then I can go prepare the right weapon and come back. One server does not have SMB, which is strange. So I try to connect it. I'm assuming it's the ADSL router, because all the small businesses, they're using ADSL. And you connect to an ADSL, it has a web interface, which looks like there's a title on the top, there's a menu on the left, and then the screen on the right. And I get this. Now, if you look at it, this is actually the HTML file, but for some reason, the browser doesn't parse it as HTML. But if you played around with it, you know to look for the direct, see there's an iframe here of the part that's interesting. So I'm like, okay, let's just go directly there, and I get this. Printer name. Oh, that is the printer where they print the bills. Now, technically, that's not very interesting. I mean, I can leave an obscene message, but we don't want to tell them that we were there. However, this reveals one more crucial piece of the puzzle. As I'm an attacker, I'm a hacker, I build an intelligence map of my objective, of my target, by collecting pieces of information from various places. And here, I actually now get the real IP address of the gateway. This is indeed the ADSL, and of course, as you would expect, they have access control. Anyone wants to guess the name and password? Admin. Correct, of course. And there you go. Now, why is that dangerous? There are 2 very dangerous things that I can do with that. One, I can enable the option for remote administration, and then just go home and connect to it. There are 2 problems with that. The first one is that it's a menu option, so someone might actually notice it and disable it. And the second is, if they actually disable it, then I'm out. And not only am I out, they actually know I was there, so it's going to be a lot harder to come back in. However, how many of you know by heart your DNS server IP address? One. You probably said it yourself. So most people don't. If I change the IP address of the DNS, it means that every time, it's called DNS hijacking, every time your computer tells the internet, hi, I want to go to google.com, what's the IP address? It's going to get an IP address that I control, which means the traffic is not going to go to Google, it's going to go to my server, right? And guess what? This is a 3-year-old presentation. And it turns out that I was either predicting the future or giving ideas to bad people. There's actually a malware now that does that. It comes with an enumeration engine to scan ADSL routers, try names and passwords, and if it finds it, it changes the DNS IP addresses, and it does exactly that. Okay? So, to sum up, it was a cash register, and it's a local server. That's what the device is intended to do. What I actually get, credit card data, customer database, maybe supplier database. Now, what sophisticated hacking tool do I use for that? I use an off-the-shelf MacBook Pro and a free software. So all the sophisticated weapons you saw at the previous presentation, I don't need that. This is all free. Everybody can have that. Really. And it turns out that the unattended wall port is a very common problem. This is the medical clinic that I go to in Tel Aviv. A very common problem is the attendance clocks. When you punch in and punch out, they usually sit on the corporate network, the same network where everything else is. And here's the wall port. And there's actually a free one here. So all I have to do is come and connect my computer to there. And guess what? Does anyone recognize this box, this little symbol here? This is a Raspberry Pi. Okay, this is a computer on a little board. The actual size, if you take the board out, this. Okay, this is how big it actually is. It's only inside. And the last version of the Raspberry Pi comes built in with Bluetooth and wireless. Okay, and you can 3D print your own box, so it can be white. And all you have to do is put it like here and write medical stuff do not touch. Now who's going to touch that? No. And now you connect a fully fledged computer running Linux with all the penetration testing tools and the wireless network to the corporate network. And all you have to do, if the first talk was about air-gapped network, this is no longer air-gapped, because now your internal network is on a wireless network. And now I can go across the road, across the street, sit in my car, and connect to your network, right? And your firewall is not going to find anything because there's no traffic going outside. A hospital in Tel Aviv, they have two different wireless networks. One is for visitors, patients, and the other one is used by the medical staff for all the medical records. And it's super encrypted. But what helps is a super encrypted wireless network if all you have to do is disconnect the access point from the wall port and connect once again to this device. Now I've bypassed all encryption. I've bypassed all encryption, and I'll now have my own wireless network running there. He's gonna fix my phone. This is an ATM at an airport. And just in case you're not sure, it actually says ATM. And once again, this is a 3-year-old presentation. There are now hackers doing that. They are building devices. Let's see if it works. It does. They're building devices and they're putting them on ATMs and they're stealing money. This is happening in real life. And even at IT conferences, you would expect people to be secure, but it turns out that they're not. This is a very important conference in Japan. It's called Code Blue. If any of you guys live in Asia, try to go there. It's really good stuff there. This is a server room. It's unattended. And you know how they prevent people from going there? There's a sign. And it says authorized personnel only. You know what? For Japanese, it works. But hackers are not Japanese. Or the hackers that target Japan, they're not Japanese. So this guy, his name is David. He works at Kaspersky. We're good friends, David Jacoby. We go to all the conferences around the world together. We speak at all the conferences. Him and I, we have this thing now. You're going to see it in all the slides. We access this stuff. We take photos, and we put the photos in the presentation right before we present them. So people see photos from the location that they're in, right?
What should we expect from
I wanted, but the train came late, so I didn't have enough time. I usually do. This is even worse. This is a hotel in Gothenburg in Sweden, where there was another conference. And it turns out they have this wonderful device. If I'm a user, this is the best thing ever. It's a device you can actually check in and check out. You come in with your credit card, you have your reservation, and this device prints the room card. It encodes a room key to open your room. But if you look behind it, once again, this is David, the network is totally accessible. I can hack that like this, and I can print a room card for every single room in the hotel. Think about that. And this is not all about nation state, espionage, blah, blah. Common thieves. And there will be no trace, because if someone checks the logs on the lock, it will have been the legitimate room card that opened it. What can you say, right? And this At a security exhibition, someone left their computer reading mail and left. So this is again David, this is Peter Cruz, he's Danish, he has a great cybersecurity. We do this thing all over the world. Once again, conference center, if you look underneath it, it's a complete computer. This is the mouse. You can just connect to it and you're in the network. You can do whatever you want. This is Poland, secure Poland. Hospital. My dad was in the hospital, they have this device. I was supposed to have 30 minutes, how come? This is for patients. It has USB ports, I'm running it, right? It has USB ports, you bring your keyboard, and you power it on, power it off, boom, BIOS, no password. So now you can boot from your own USB device. And when you do that, Kali,
Wow.
okay, the operation system of choice of penetration testers, gives you full access. Turns out, I'm gonna brush through that. The network is encrypted, which doesn't happen often, but because this is Linux, the encryption keys are in a text file, so you copy them, and now you have access to the encrypted network at a hospital. How far does it go? Well, you don't know, but we made a proof of concept, and then accessed the server. And this is a hospital with 3,500 beds. If I infect the server, I can create a 3,500 botnet. And everyone that passes their card, I'm going to steal their information. Brushing. And the last one, this, by the way, I only use the USB drive. An airport. You can buy stuff with this device while you're waiting for your plane. And it's a touchscreen. And if you look underneath it, once again, all the ports are exposed. You take out your USB keyboard. Turns out you're the administrator on the WinXP. There are 74 identical devices on the network. It's connected to the outside world. Okay, you can now implant something and have it transmit or connect from the outside world. Turns out they actually have VNC with an RC4 encryption key, but since I am on the computer, I can just print the key and take it with me. And even the router gives you additional information. So, skip that. Last slide. Local networks are rarely monitored as protected as the internet gateway. We perceive the threat to be coming from the outside, last slide, to be coming from the outside. So the thought is that once you're inside, that's it, you're good. But it's not like that. And many devices that are publicly accessible do not get hardened, especially in places like a university. There are many devices here that anyone can access. Printers are